Okay. So today we're going to be discussing a recently published paper titled The Effect of Relative Encoding on Memory-Based Judgments by Marissa Sharif and Daniel Oppenheimer. Now I want to start off by saying that I am a big fan of these authors, and they've been doing a lot of great work lately. Plus, I think you'll be able to relate to a lot of their findings. So the authors start off by discussing how research has shown that we are bad at identifying identifying the absolute magnitude or total quantity of a stimulus, but we are very good at discriminating stimuli from one another. For example, it is difficult for people to accurately identify the number of dots within a given pattern, but we are very good at figuring out which pattern has more dots. Now, this finding is really interesting because it demonstrates how quickly and efficiently we can make some judgments, but not others. For instance, if I quickly present you with this image and ask you to tell me how many dots were in figure B, you may not be able to do so very quickly. But if I present you with this same image and ask you to tell me which pattern has more dots, you might be able to tell me that figure B has more dots than figure A. Now, related to this point, other researchers have shown that when assessing a stimulus, people represent where in the distribution that stimulus lies rather than the absolute value of that stimulus by making either an ordinal judgment or an interval judgment. Now, the difference between these judgments are subtle, and they may be difficult to keep separated, but I think they're incredibly interesting because an ordinal judgment refers to people's ability to determine that one stimulus is better than another, but not by how much, whereas an interval judgment refers to how people can determine how much stimuli differ from one another with regards to relative terms, but not absolute standards. And essentially what this is saying is that people's evaluations are heavily influenced by surrounding stimuli. Now, to further demonstrate that people's evaluations are heavily influenced by the surrounding stimuli, we can look at a commonly used circle illusion used in psychology. Now, this illusion is awesome because it demonstrates that despite the orange circles being the exact same size, the circle on the right looks much larger than the circle on the left. This is because we tend to judge circles as being smaller when they are surrounded by larger circles. Now, the takeaway from this illusion is that our judgments are often informed by relative information, such as the surrounding circles, rather than absolute information, which would be the exact size of these orange circles. Now, although our judgments are often informed by relative rather than absolute information, there are often times in which we must make a decision without the help of readily available information. Put simply, it is not uncommon for our judgments to rely on our memories of past information. Now, interestingly, prior research has shown that when we rely on our memories to help us with a given decision, we rely on our initial impression of these past evaluations. Now, this tends to be much more efficient than recalling the details of that past evaluation and then re-evaluating all of our options. Now, the authors wisely point out that if our judgments are relative rather than absolute, and if we rely on our initial impressions of stimuli, then do our evaluations of prior stimuli change as we acquire new relative information. Now, the authors discuss a great example that I think perfectly sums up their research question in a way that you might be able to relate to. So imagine that there is a college student who eats mainly dorm food. However, the student is able to occasionally go out and eat at a local pub. Now, the food that the student has received at the pub is among the best food the student has ever had. Eventually, the student graduates and is exposed to a variety of new food sources, which are likely to be better than the food he or she experienced at the pub. Given the exposure to new, better food sources, how would the student recall the quality of the pub food? Well, to try and answer this question, the authors conducted a series of studies. In the first study, the researchers had participants listen to several song clips at 2 different times and then make evaluations about who they thought was the best singer and who they thought was the worst singer. Now, I think the author's methodology in this first study is fascinating because in this study, the researchers had 2 very bad singers, 3 average singers, and 2 very good singers. Now, participants were randomly assigned into 1 of 2 conditions, And in the first condition, which the researchers called the T1 top condition, the participants listened to 2 bad singers, and then they listened to an average singer. In the second condition, which the researchers called the T1 bottom condition, the participants listened to 2 good singers, and then they listened to 1 average singer. Now, the reason why I think this is so interesting is because the authors use this methodology to make the average singer look relatively good or bad by comparison. Now, after listening to these individuals, the participants completed a distractor task, and then all participants listened to 2 more average singers. Participants were then asked to select the 1 singer that was the winner and then 1 singer to be eliminated. Now, what the authors found in this study is really interesting, because as you can see in this graph, when the average singer was paired with the bad singer here in the T1 top condition, the average singer was frequently selected to be the winner. However, when the average singer was paired with a good singer here in the T1 bottom condition, the average singer was frequently selected for elimination. Now, this is fascinating because these results demonstrate that the evaluation of the average singer depended on his or her relative comparison to either a very good or a very bad singer. And the initial evaluation of that given stimulus did not change even after being presented with additional information, such as the 2 average singers. Again, these findings are pretty straightforward, but the manner in which the authors tested this question is really clever. In the second study, the researchers had participants watch toy cars race along the track at 2 different times and then make evaluations about which car was the fastest. Now, the authors tried to get at their question in another unique way, and I think their approach to the second study is much more interesting than their approach to the first study. Now, in this second study, the researchers had 3 different toy cars consisting of a slow red car, a fast yellow car, and a moderate speed black car, which they refer to as the target car. Now, similar to the first study, participants were randomly assigned into 1 of 2 conditions. And the first conditions, which the researchers refer to again as the T1 top condition, the slow car raced the moderately paced black car. And in the second condition, which the researchers called the T1 bottom condition, the fast yellow car raced the moderately paced black car. Now again, the reason for doing this was to make the moderate car look relatively fast when racing the slow car, or was to make the moderate car look relatively slow when racing the fast car. After watching the 2 cars race, the participants completed a distractor task and were then asked to watch a final car race along the track. Now, the really cool thing about this study is that although that they were told that the car they watched the second time was a different car, it was actually the same black car as before, which they refer to as the decoy car. Now, participants were then asked to rank the 3 cars that they watched according to their anticipated speed. Now again, the authors were able to find another really interesting effect. And as you can see in the graph, for the second study, when the moderate speed car was paired with the slower car in the T1 top condition, the participants rated it as being the fastest. However, when the moderate car was paired with the faster car in the T1 bottom condition, it was rated as being the slowest. Now, the great thing about these results is that they also demonstrate that our evaluations of a given stimuli, such as the speed of the toy car, is dependent on our earlier evaluations. Overall, I'm really impressed that the authors were able to find such consistent results across these 2 studies. Now, in the third and final study, the authors had participants record the number of butterflies that landed on certain flowers. Now, a really unique aspect of this study is that the butterflies and the flowers were not real, but instead they were just aspects of a computer program. Which, in my opinion, that's a really clever idea to get at this. Now, for the sake of time, I'm not going to be going over the specifics of Study 3, but I want to point out that Study 3 was essentially the same as Study 1 and Study 2 with regards to what they found. Specifically, participants tended to rely on their memory to make relative judgments. Now, the fact that the results were consistent across the 3 studies really goes to show that the authors' manipulations were well thought out and were very appropriate for this type of research question. Now, prior research has shown that people encode information relative to the context that they're in, and that when making judgments from memory, people rely on their initial impressions. That being said, I think it is fascinating that the current study was able to demonstrate that people rely on their initial evaluations of a given stimuli, even when the contextual information changes at time too. Now, in 3 separate experiments, people encoded information relative to the context at time 1. For example, an average singer was presented alongside either a good singer or a bad singer at time 1, or a moderately fast car was paired with a slow or fast car at time 1. Impressively, across all 3 studies, the authors found that the participants would not update their decisions and evaluations after being presented with new information. Specifically, average singers were seen as being the best when initially compared to bad singers, and were seen as being the worst when initially compared to good singers, despite being presented with additional information later. And an average car was seen as the fastest when initially compared to a slow car, or was seen as the slowest when initially compared to a fast car, despite being presented with the same car later. Again, I think it is fascinating that the authors were able to find such interesting effects using these simplistic yet creative methods. Now, in sum, when making memory-based judgments, we tend to rely on the context in which the original stimuli was encoded. Now, because of this interesting finding, it is important to mention that we must be aware of this bias, and our initial evaluations may bias how we encode later information. Given that many of our judgments are based on memory, it is imperative that additional research using similar effective methods try to seek to understand how and why people make judgments and decisions.